Welcome back to Public Affairs on Peach. Our look at the Atlanta Science Festival continues with Emory University senior chemistry lecturer, Dr. Doug Mulford. Thank you so much for joining us.
Thank you for having us.
We've been having some fun in here with some of the goodies. Why is science so important in our everyday life?
It is your everyday life. Everything we do is interacting with science in different ways, and a lot of times we forget that. And so one of the things that I try to emphasize is really how science is in everything you do every day, and that it's fun.
So are some of the things you do for your students at Emory?
I do some of these for the students at Emory. I'll also be doing it at the big expo at the park next weekend.
Oh, cool. Okay, let's see what you've got, Dr.
Well,
Doug.
I got 3 different things for you. So first thing is, go ahead and take a breath. All right, breathing in some air, got some oxygen, other things in it, breathe out. Okay, so you breathe out some carbon dioxide. Now, carbon dioxide, very common in our atmosphere, and it doesn't seem like it at first, but it actually is a little bit acidic, and it's part of what leads to acid rain. So I want to be able to show that. So I have a large container here filled with water right now. It has a little bit of a salt in it just to make it a little bit basic, but I'm going to show you some color. So one of the things that we talk about in science a lot, thank you for reminding me, science is, we need to be safe, is in chemistry, we're often trying to study things that are too small to see. So we need some other way to know what's going on. So I have here is a chemical indicator. It's a chemical compound that changes color based on how much acid or base is present. So if you look, what color do we have here?
Orange, I
We
believe.
got orange. So we're going to pour in an orange compound, and as it goes in,
Ooh, it's like purple or blue.
a little bit of science magic there. So it turned purple. So that tells me that this is basic like a soap. So right now that's like a soap in there. So I'm just going to stir that up. Now, we could sit here and we could try to breathe through this really long straw for a long time, but we don't have that much carbon dioxide in our lungs. So instead, what I have is I have a little bit of frozen carbon dioxide.
Oh.
This is dry ice.
Okay.
All right, so this is about 100 degrees below zero. So we're going to put some of this in there. All right, always good to have a little bubbling and mad science going on. So this is going to take a little bit of time, but we're going to watch the color. So we have a nice, we started with a nice purple. Let's add a little bit more, have a little fun with that.
Now, what's coming out over the
So
top?
what you're actually seeing is a little bit of a cloud forming. So this is very cold, and it's causing the water that's in the air, in the moisture in the air, because we are in Atlanta and we have humidity, and it's causing it to condense into a cloud. And that's what you're seeing there. And you might notice that the color's already started to change a little bit.
Yes,
It's moved towards green. And eventually we're going to get towards a yellow. And the more towards yellow and red, the more acidic it is. So we can see the acid. And this is one of the things that we worry about with acid rain, because this type of an acid would dissolve something like a marble statue.
Oh, wow.
Or anything like that. It helps acidify the water, and that's not as good for the fish and other animals that live in the water. So we have to be very careful with how much acid is in the environment and available for that.
I love that. Can't touch that. Is it dangerous to touch?
No, that's fine. It's just you can actually catch a little bit of a cloud there. So have fun with that.
Okay.
All right. So as we do that, the other thing then, next one I want to do is, out here in Atlanta, I'm from California. Okay. And when I came out here, everyone said it never snowed in Atlanta.
It has.
It does, yes. A little more often. It's supposed to do that once every 10 years. Does it a little more often. But we're going to make a little bit of snow here. And so what I have is some white powder. And this is a little bit of a plastic. Now, it has a scientific name of sodium polyacrylate, but really all it is these long chains of plastic, kind of like spaghetti, and they're all mixed together, and they have a little bit of sodium in there. And so what we're going to do is we're going to add some water. And what's interesting is looking at just a little tiny bit of powder in here, and we're going to put in a full 2 liters of water.
Oh, wow.
And we're going to see what happens when we pour all of this in here. All right, let that sit just
It's like
for a second.
baking soda.
Like baking soda, but
Oh my goodness, it solidifies.
it
What is it
absorbs
doing?
all that water. So the long strands of the plastic are absorbing the water, and we just made snow.
Oh my goodness.
So now this is not the regular snow that we get
Don't they
outside.
make it Snow Mountain?
No, there's a little different. This one's plastic snow, but they do use this in the movies, because this snow does not melt under the hot lights.
my
So a lot of the movies you see will actually use this as the prop, so that they don't have to worry about melting the snow all the time.
Very wet. I like
It is,
that.
and it even feels a little bit cool.
Yeah.
So that one's a lot of fun.
That's cool.
And then one more, speaking of cool, we're going to go to very cold. So what I have here in this container, this is just a really big thermos, is some liquid nitrogen. Now, when I had you breathe earlier, you breathed in mostly nitrogen, all right? That's actually 77% of the air is nitrogen. And so to get this into a liquid form, we have to make it cold. And I mean really cold. This is 300 degrees below 0 Fahrenheit. So it's really, really cold. But one of the things we like to look at is how does temperature affect things? And so I have a couple things that I want to look at. So the first one is that we have a flour. So we're going to see how temperature affects the flour.
It's a real flour.
It's real. All right, so we're going to put our flour in here. All right. Now, again, you're going to see a little bit of a cloud because it's causing the air to condense. And in fact, you have moisture in your lungs, right? So you can breathe on it and do a little science there.
Wow.
And then Easter's coming up, and a lot of people, I understand, actually eat Marshmallow Peeps. I don't. I find that Marshmallow Peeps are great to do science experiments on. So we'll go ahead and just have a couple of these fly into here. So there we go, Peeps.
So is it liquid in there? Oh,
Yeah,
I felt that.
It is a liquid in here. And then one more thing that I want to do for you. You may have had one of these twisty balloons sometime as a kid or even as an adult. Balloons are always fun.
Very nice. Better than me.
That's my summer job.
Yeah.
So we're going to take this now, and I'm going to take this 3-foot balloon, and I'm going to cool it down. And when I cool it down, right now there's air molecules in there that are bouncing all around, and they're hitting the walls.
Right.
But as they get cold, just like we do on a cold morning, they're going to get tired, and they're not going to move as fast, and so they're not going to hit the wall as fast. And we're going to see what happens with them. So I got a 3-foot balloon here. Oh, I'm going to pop that one.
Woo.
That's okay. Live science.
That's why we have on goggles.
Another one, and it is why we have goggles.
About a minute left, Doc. So
We'll do this one a little faster then.
okay, sounds good. Can I maybe look at the flour while
You can look at the flour.
Wow.
In fact, yeah, let's go ahead and put the balloon in. Get that eye with. So here's the whole balloon. So those molecules are slowing down. They're moving slower there. Okay. So now when things get cold, you have to be a little careful with them. Sometimes they get a little more fragile. So if we take our flour, and we've got our table in front of us here, and
Oh, Doc. It's gone.
it's gone. It's science.
Wow. All right, let's get those peeps down there.
We'll get the
About
peeps
30
in just a second. All right, well, let's take out the balloon.
Ooh.
Let's take the balloon out, and we let the balloon warm up, and it goes both directions. Not only did it get smaller, but it warms up a little. Oh, so this one's not going to warm up quite as well. We're rushing a little bit, but our poodle comes up as a poodle.
Cute.
So we have special liquid nitrogen. Now, last but not least, we need the peep.
And they take that long? Because that shows you what that does to your stomach then.
Yeah, peeps are actually very sturdy. Now, all good science involves a hammer, or at least I think so.
Oh, goodness.
So let's take our peep here. Whoa.
Oh, he's falling apart.
He's trying to fly. He doesn't fly so well. They don't live down in the Arctic, and we can tell because if we get a peep very cold, well, and a hammer.
Oh.
Whoop, there goes the peep.
Wow.
So you got to have some fun with science. Okay. And so it is important to know what happens with different materials as they get cold, which is why we study these things.
I love it. Thank you so much.
Yeah.
Oh, I love that. We've got some animals waiting in the wings. So don't go anywhere. We are continuing with this special science edition. We'll be right back.